Welcome back, my friends. Welcome back to another lesson about volume, the space within, right? It's pretty cool. You've probably been looking all over the place for rectangular prisms to measure those 3 dimensions and find out how much space is inside them. Utilizing that fantastic cubed unit, but maybe cubed inches and cubed centimeters and other cubed things as well. It's pretty cool to have that cubed unit. But you can apply this to other things too, like things that might not be so easy, like a cylinder. What do we do with that? Might have some issues, right? Well, let's approach it just like we did everything else. Let's try our formula out, but before we try the formula we have for volume, and yes, I know you can see that circle and it's making you uneasy. First, look at this can. Look at its shape. Shaped like something, right? Maybe if I do this, it might be a little bit clearer to see what I was talking about. Do you see that rectangle? It is a rectangle, right? In fact, this is just a rectangle. This is actually the exact size that if I took the skin off that can, it would be a rectangle exactly like this. Look at that. Well, if we were doing surface area, that'd be great. But I did want you to realize that there is a rectangle sort of in that shape. Okay, and we got that circle to deal with. Well, let's get that there, and let's get a whiteboard to do some work on. Hey, where do you think you're going? Okay, let's get you standing up. Let's make sure we have a ruler, and let's get our formula for volume down. We'll try the one we did with the rectangular prism. Maybe it'll work. Maybe we'll discover a new one. Volume equals, remember we could do length times width times height, but we also discussed how we could do the area of the base. I'm going to write that variant down, and I suggest you do that as well for this one. So volume equals area of the base times height. Hey, one of you just said something very interesting. You said, I know the area of the base of that because I know that the base is a circle, and I've done area of a circle. Well, my friend, you have the right idea. Why don't we try it? So let's write this down again with the formula for area of a circle in place of area of the base. Do you remember that formula? Yeah, the one with pi in it. Pretty delicious, huh? Pi r squared, because it's pi times the radius squared, or the squared radius. And how about the height? That would just be easy enough to measure. So then the first thing we've got to do is solve for the area of the base. And to do that, we're going to have to figure out what the radius of this circle is. Well, this time I'd like to use centimeters. I am a metric person. So, using our amazing powers, we can sort of see that the diameter of this circle is 7 centimeters. But we don't want the diameter. What do we want? The radius. So what's half the radius? 3.5. So why don't we expand this out? Pi is 3.14 times the radius of 3.5 squared times the height. And we have to measure that as well. Ooh, a nice even 11 centimeters. That should help us out a little with all these other decimals to work with. 11. So 3.14 times 3.5 squared times 11. Let's do one thing at a time. Let's solve that square first. What is 3.5 squared? 12.25, or 12 25 hundredths. Try to fit everything in here. And times 11. I'm thinking we should save that 11 for the very end, potentially, because we've got to figure out this 3.14 times 12.25. Pull out your decimal fraction multiplication hats, friends, and give me a number for this. 38.465, and we're going to multiply that by 11, and then we should have the volume of this can. Like how much soup we could pour into it, right? Okay, 38.465 times 11. All right, the volume of this can is equal to 423 and 115 thousandths centimeters cubed. I could fit 423.115 cubic centimeters in this can. Seems like a lot, and if we poured it all out on the table, it would make a really big mess. So why don't you go find out what kind of a mess you can make by finding another cylinder, maybe a really big one, and finding out how much would be in that cylinder, and then you can think about how long it would take to pick it up if you slosh that all over the floor. Well, my friends, you've discovered finding the volume of a cylinder. Go get lost in it and have fun.